want to talk a little bit about the engine program here at CNH Industrial Reman. Some of the things we do that we feel separate us from other people in the industry is, one, we emulate the OEM process as much as possible. And some of the ways we do that is with the torquing of all of our fasteners. All the fasteners on our engines are torqued with DC torque tools. We use some cordless torque tools that's actually used in the aviation industry, very new to the remanufacturing industry. It's very expensive methods of torquing fasteners, but it's by far the best method of torquing fasteners. So what that does is that enables us to really control our torquing processes, which on down the line will help eliminate leaks and things like that, especially on small fasteners. So once we've made the investment in that process, then we go to the next process at the end of the line, which is where we check for leaks. And the way we test for leaks is we have an air decay process. This is a computerized process that is very engine specific. The programs are actually built by our engineering department for each specific engine model. We actually fill a part with air, measure the air loss, and we actually measure that out to the 5th digit beyond the decimal point. And what we're looking for there is any sign of leak that the customer might see. So the reason we use air is 1,400 times less viscous than 10-weight motor oil. So if we were testing with oil, even if we were going through a 2 or 3 hour test, there could still be things that got out into the field. So using the air decay method, we kind of eliminate that process. So then once we complete that, we're confident that our engines are leak-free. Then we go on to our final test at the end of the line. Our basic level engines go on a spin tester, which is a custom designed machine. Rather than just spin it and look for oil pressure, which is common to the industry, our machine does a lot more than that. And again, it emulates the OEM process. So we're measuring rotational drag, we're measuring vibration in 3 axis, we're measuring crankcase pressure. And with all of that, we're also gathering the data from that. So we gather data 20 times a second. So we accumulate a huge amount of data in a relatively short test. So what that does is to make sure that that all the parts are in the engine, all the parts fit well, and the rotational drag tells you that the engine rotates with the proper amount of rotational drag that it should have. So once we do that, then the engine is ready to go on to paint. If it's a replacement level engine, they go to the dyno test, which is actually a hot running test. And in there, we measure all the performance parameters that the customer would see. So we're setting the RPM, we're checking horsepower, we're checking torque, making sure the torque is in the correct RPM range. We're measuring fuel volume, exhaust temperatures, opacity, and any other performance parameters that would be required on that engine. So once we do that, we're very confident that we're sending an engine to our customer that is one of the best engines that you could buy in the marketplace today.
At CNH Industrial Reman, our remanufactured engines are assembled by trained technicians to be good as new, or even better. Unlike rebuilt engines where only failed components are replaced or repaired, we replace and test every component to prevent any problems. Our state-of-the-art technique uses advanced manufacturing systems that provide unequaled control, creating a better product. Throughout the process, technicians follow precise control plans and work instructions per engine family to maintain the product's integrity and guarantee repeatability, which in turn ensures consistency, the key to producing quality products. Technicians fill out responsibility sheets and operator sign-offs with a checklist of every required measurement and completed step to ensure quality through heightened accountability. We start with a process called kitting. New components are sourced from our warehouse or the Kanban and loaded onto a rolling cart that travels with the engine. This helps us track and regulate every step and component to make sure every engine has the right parts for the job. The engine block is secured to a motorized engine stand, allowing it to easily glide through each of the 5 stations in the assembly line. At Station 1, the technician plugs external oil galleys, installs bearings in the block, and inserts the crankshaft. A twin-spindle DC torque tool suspended on an ergo arm, allowing the technician to easily and accurately tighten the main cap bolts and secure the crankshaft with unparalleled precision. Bolts are torqued at the same time to the same measurement to prevent a cantilevered load on the bolts and the crankshaft. At Station 2, the technician installs pistons, rods, in the camshaft. The twin-spindle torque tool ensures the rod bolts are accurately torqued. This best-in-class technology removes the potential for human error, as it alerts the technician when the exact torque setting has been achieved, ensuring precision and accuracy every time. At Station 3, the technician installs the oil pump, front cover gasket and front cover. Then they add the front seal, rear housings, camshaft gear, and the injection pump gear. The technician records the gear lash on all gears for proper specifications. Finally, the flywheel housing is installed. At Station 4, the technician installs the cylinder head, sets the valves, and mounts the rocker cover and gasket. The oil pan and pickup tube are installed and torqued. After this station, the engine goes through rigorous air decay testing that checks for leaks in the oil, water, and fuel systems. The block is pumped to 3 psi for the oil side, 15 psi for the water side, and 30 psi for the fuel side. And a state-of-the-art machine performs a pass-fail test to ensure there are no leaks out of the engine block. For a basic engine, also known as a long block, a spin test is also administered to measure oil and crankcase pressure, RPM, vibration, and rotational drag. Once the engine passes the spin test, it goes to the paint booth. At this point, long block engines are complete. Engines that have been trimmed with top-end parts such as fuel line, pumps, injectors, and pulleys go through another round of rigorous testing. The air decay test is repeated to check for fuel leaks, and the dynamometer tests oil pressure, exhaust temperature, horsepower, water and oil circulation, and overall functionality, validating all performance parameters. We also completely lubricate the engine, giving it robust protection during storage and shipment. Once the engine passes this stage, it also goes to the paint booth, where it gets a fresh coat of paint to look as good as it will perform. As you can see, there's a high standard of quality that sets our Reman engines apart from rebuilt or repaired engines. Our state-of-the-art techniques and unequaled quality control is built into every step, giving dealerships and customers true peace of mind. When you want industry-leading value, you want remanufactured parts from CNH Industrial Reman.